Hello and welcome everybody to the third session of our follow-up webinars after the start we have been making back in January this year with 3 intensive workshop days on the sustainable aviation fuel subject. My name is Ralph Kosman. I'm with the EASA, the European Union Aviation Safety Agency, since 2009. And I'm today speaking to you as the operational manager of the European Union Southeast Asia CCCA CORSIA project, which is funded by the European Union and brought into life through close and intensive cooperation and collaboration among and with all ASEAN member states, with a joint aim to reduce CO2, the impact of climate change, and to reduce CO2 emissions in civil aviation. It's a great pleasure to be with you again, and I'm excited to see so many colleagues being interested on the SAF subject and what we are doing. I will try to avoid a longer speech today so that we can dive straight into the main subject of today and to focus on the technical aspects being presented to you by my colleague Andreas Busa, who's trying to provide you and give you an update and share his latest knowledge on, as the title is saying, on SAF certification and new pathways which are possible to go in the foreseeable future or being under development. SAF initiatives and SAF enablers, and last but not least also SAF updates and latest developments from Andreas' perspective. If I may briefly go back and try to explain to you how this webinar today is embedded in the overall project. We are in this CORSIA project trying to support the ASEAN member states, as I just said before, to reduce CO2 emissions in civil aviation. We are trying to support and help on CORSIA implementation itself, the creation of state action plans for the reduction of CO2, support to provide functional tools to track and record and report data emissions, and on climate change policies. The areas of actions are very similar, as said before: CORSIA implementation, state action plan creation, climate change policies, and data emission management system creation and implementation. I'm not alone. We're a team, an EASA team of 3 colleagues. On top you see Santiago, I think he's also connected, and Rebecca. Both are sending their regards. And we are going to open, or I'm going to open, activate on the bottom right corner of your screen, the so-called Slido tool, whereby we and I would like to encourage you to pose any questions you might have at heart straight to us. I'm trying to monitor these questions, and after Andreas' presentation, I'm trying to revert to your questions, and Andreas is going to do his best to give you a satisfying answer wherever he can. So don't hesitate, please. Any question you may have, let us know. We are recording the session, and we're going to share this with you later on our internet website. Here, there's the access code for the Slido tool. It is Oscar Alpha 4 Delta Juliet Alpha. Oscar Alpha 4 Delta Juliet Alpha. And you can also access it through scanning the QR code that I'm showing here. So this was all from my side, and I would like, Andreas, if you are ready, I would like to hand over to you. And I'm looking forward to talk about and to listen to your update on SAF certifications. Thanks a lot, Andrea, for supporting us here. I have the feeling that I've missed one slide actually, which was showing your bio. Andrea, you are here.
Should I go back? Do you want to show it?
2009, right? You're our sustainability officer. You're working on these subjects every day, and I think many visitors have already, or participants have already seen you back in January. I think you were holding 1 or 2 sessions also on this subject, on SAF certification in the past. And again, thank you very much for helping us here. And I've just learned that we have the same background. I was also working in the consultancy branch before joining EASA. So again, thanks a lot for helping us here. And the floor is all yours, Andreas.
Okay, thanks, Ralph, and good afternoon and good morning, everyone. Yes, as Ralph said, I'm sustainability officer here at EASA, and I joined a little bit over 3 years ago, no, almost 3 years ago in October. And yes, as he said, I have a background in environmental sciences, worked in a consultancy, environmental consultancy before joining EASA, and now my daily work revolves around sustainable aviation fuels. And today I want to give you a quick, or not quick, but a more detailed overview about sustainable aviation fuel certification. We talked about it briefly in January already. And I started off with some chemistry. I'm not a chemist, but I show you this beautiful picture anyway. So background, what is aviation jet fuel? Typically you have the globally most accepted standards are basically the ASTM D1654, which is from ASTM, which is situated in the US, but it's a global organization for standardization. And you have the DEF standard from the UK. And of course, you also have national specifications, but they basically are based around those 2 global accepted ones. And within there, you have the Jet A1 fuel, and this is basically a range of hydrocarbons. You have so everything is basically set into ranges, right? So you have a range of boiling points that need to be met, density. The aromatics have to have a certain maximum value, the same with sulfur content, etc. And from there, or in there, you have your aviation jet fuel. And how is that? Does that then evolve basically to what we are talking today? The main reason is that within the D1655, which is this Jet A1 jet fuel, it among all the properties that are defined that I showed you in the earlier slide, it already says in this specification from what this fuel should be made of, and it should be or shall be predominantly made of hydrocarbons derived from conventional sources. So that means based on that wording alone, you cannot just add an alternative jet fuel that is made from biomass or from something else to that specification. So the community, the aviation global and standard community, of course, had to deal with that. So that brings us basically to what we will talk about today. Aviation fuel approval is tied to the aircraft and engine type certificate. So an aircraft is certified to operate on a specific fuel, in this case, Jet A1, Jet A fuel, which is the conventional jet fuel specification, right? And let's assume you are a producer of a novel jet fuel. You have to go through a specific process, which is the D4054 industry process, to determine that whatever you are producing there is equivalent to conventional jet fuel, so that it can be safely mixed with the, as I said, conventional jet fuel. Because everything that we are talking about today is referring to drop-in fuels, which means that they are basically equivalent to the Jet A1 fossil jet fuel. They can be safely mixed, which means that they can be used basically in all existing aircrafts today. So as I said, you have to go through this process. And after this process, which I go into detail later, if determined equivalent, a new annex will be added to the specification D7566, which is this drop-in fuel specification within ASTM, which basically lays out for each novel or specific new pathway, there's a specific annex, which basically then lays out how it should be produced, the feedstocks that can be used, and all the other properties. And since this D7566 drop-in fuel meet the conventional fuel spec. As I said, they can be safely mixed. They're basically equivalent and hence are approved for use in all existing aircraft without that the certificate for the aircraft or engine type needs to be changed, right? So otherwise you would, of course, the process would be much longer and basically very cumbersome. So basically, if you are added to 7566 or you are producing a fuel that refers to those in D7566, that means you're basically equivalent to Jet A1, and that means you can be operated in all existing aircraft. So the question is, of course, how do you come to that point? As I said, this process is called ASTM D4054, and I will show you a lot of those beautiful process diagrams. The main thing is basically a testing program, right? So you have a different kind of testing, which I will show you in a minute. So a lot of chemical evaluations, specific specification properties, and depending on where you are in the process, you need more fuel and more time, etc., and more money, of course. And one important part, of course, is the OEM review. So the result of those tests are reports that then go to the OEMs. So the engine manufacturers, for example, that review those reports in order to be balloted then within ASTM, so that a new specification can be added to this. So this shows you a little bit better what I'm talking about. So you have three phases basically. Phase 1 is tier 1 and tier 2 testing. So we are talking about just a little amount of fuel, and which looks basically at specification properties, but I have another slide with more detail on that. So the end of the phase 1 would be a research report that then goes to the OEMs, and they also then will be decided whether a phase 2 is even necessary. So what you can see here, it doesn't mean that all that needs to be done in order to get a new fuel added to the specifications. But if decided that there needs to for phase 2, then there's component rig testing, actual engine testing, another research report, another OEM review, and then finally that would go then to the SCM balloting process.
Andreas?
Yes.
I know a big challenge is to have hold a very long monologue and speak into this little box in front of you. If you want, I can drop you a question here and there in between, but I would leave it up to you. Just let me know if you're ready for a question. I can pose it, or I do it at the very end. What would be your preference?
I would continue first until the first basically chapter done, and then we can have questions. All right.
Sorry for interrupting, Andreas.
No problem. So this slide, I hope you can read it because I can't really. I hope the quality is good enough. But anyway. So this basically shows you the different tiers. On the left side, tier 1 and tier 2.
For a second, interrupting, Andreas, there's a zoom function on the very top of everybody's screen. It should be, where you can zoom in and increase the percentages. Sorry for interrupting again, just technical information.
I don't see it, but well, I hope maybe, well, I can do it with my touch.
If you can do it for the audience, great, but every single visitor, every participant at their own screen can just zoom in and zoom out, or should be able to do that.
Yeah, so maybe you can see it better now. Anyway, so so tier 1 and tier 2 on the left side is basically this phase 1 that I talked about earlier, and on the right side you have tier 3 and tier 4, and you can see that especially in tier 2, the fit for purpose testing is a lot related to chemistry, so boiling points and lubricity. I'm not an engineer, so I'm reading that basically now, but you get the gist. So a lot of testing, a lot of comparison against temperature, just to see that the fuel that is evaluated is fit for purpose. And then you have this research report and OEM review. And they basically say, are the properties acceptable for engine aircraft use? And if yes, that it might go to tier 3 and tier 4, which is then basically already then at the OEMs, they define the potential test requirements. You have tests that ensure that it's compatible with the engine and airframe seals, turbine hot section component tests from the fuel system to the combustor rig tests, etc., etc. And then the last test is basically then the actual engine testing related to endurance, performance, operability. And then again, as I said, the OEM review. And if that is then approved, then it goes to the ASTM balloting process. So just a second. All right. But that's not all. There's another way to get your fuel approved within the annexes of D7566, which is a fast track process. I'm not reading that all, but what it basically means is, again, the picture from earlier. If you have a fuel that meets the fast track screening criteria, it basically means that it's even more equivalent to Jet A1 fuel. You could get it approved much faster without the rigorous testing, without so many review steps, etc. So you can see it here on the top. Basically can skip a lot or basically all of the testing. You have a different testing program and then go directly to the OEM review. But go back one slide, you can see it here at the bottom. Using this fast track means, at least at the moment, that a maximum blend limit of 10% will be imposed on this fuel. I have not touched upon that yet. All the annexes added, or all the certified production pathways, they have a specified blending limit. At the moment, the maximum is 50%. There are fuels that meet that, and there are fuels that have less. I will show you that in a second with an overview of all the fuels. But for fast track fuels, the blend limit of 10% is basically the maximum. So there it is. This is all the SAF pathways approved at the moment. You can see that the feedstocks have a huge variety. So it goes from vegetable and animal fat with the HEFA fuels, which is at the moment at least the production pathway with the highest technology readiness level, and so the commercialization is most advanced for those fuels, let's say. It's up to 50% blending limit, and at least for the next years, this is one of the pathways that will probably contribute to most to the overall SAF production worldwide. In the future, there's also biomass gasification in Fischer-Tropsch and alcohols to jet, which show a huge potential to go forward. And here the third one from the bottom is HEFA from algae, which is the first fuel that was approved with the fast track process. And there the blending limit, as I said, is for now up to 10%. And assuming that they want to go for a higher blending limit, they would need to go through the whole process. Yes, I have a quick picture on that, because I think since it's the first fast track fuel, it's worth to have an extra slide on that. So it's from a Japanese corporation initiated this production pathway. As I said, it's microalgae, and there's a cultivation, drying, extraction process, and then there's this HEFA process again to convert it into jet fuel, and that is then this NX7, which is the Andreas HC HEFA SPK. And yeah, so this is not only the first fast track, it's also the latest addition to the production to the NX. And you may already heard, and I think I have had that also in the earlier presentation in January, that another production pathway that is often talked about because they offer they offer at least potentially the highest carbon emission reduction potential, which is power to liquid or e-fuels and synthetic fuels. They're all kind of names used for basically the same thing, where you basically have electricity and CO2 and water in order to produce something called syngas, and that is then processed via different conversion options into jet fuel. And if this conversion option that you choose for your power to liquid would be a Fischer-Tropsch conversion process, that would mean that it's automatically approved under ASTM, because, I will go back, we have Fischer-Tropsch already approved as a production pathway within ASTM. So basically, only the feedstocks, let's say, you could say only the feedstock changes, and the actual production process of the fuel is the same. And ideally, to improve or to minimize the carbon intensity of the production process would mean that the CO2 source would be carbon capture and utilization, basically capturing from the atmosphere, basically. But that's not all. You see on the right the number of approved production pathways that are at the moment within this ASTM qualification process. So you see that we have 6 different, or one is inactive, so 5 different fuels going through the process now. So we will have maybe in the future more annexes to be added and more options to produce SAF in the future. And as I said, there are various initiatives and research programs to facilitate this, the fast track program, but there's also EU Jetstream program, which I'll come back to in a minute. Since I'm now going to another topic, we can have some questions for the first half.
Good, thanks, Andreas. We have Robert posing 2 questions. Robert, thank you also for that. I think the first you have briefly touched upon already, Andreas. It is the question, let me just read it as he was writing it. What is the timeline to obtain ASTMS certification under normal approach and fast track?
Okay, yeah, it can take years, unfortunately. I think it all depends. I come to that in a minute. So maybe the short answer is it can take a long time, and it can take a lot of resources. Fast track is of course faster because you need less testing. But I will come to things that might help that process in a second.
So I understand you will touch that subject later as well. And is there any? I mean, there's probably just some kind of orientation in terms of timing. I mean, without being overly precise. Any rough estimate from your perspective?
I don't have any concrete numbers at the top of my head, but I guess at least 2 years could be a good estimate that process will take. Yeah.
Thanks, Andreas. I hope I doubt anyone will sue you for this statement. This isn't right. So, Robert was having another question, and he's asking who will submit the biomass fuel for ASTM certification as a drop-in fuel.
I'm not sure I fully understand the question.
So for the biomass fuel under the ASTM certificate as a drop-in fuel.
Yes. I guess the question is who will submit the review and the research reports to the ASTM process, I guess, which is then
anticipated. Yeah, I cannot.
I guess so. I guess the answer would then be that the fuel producer themselves would go to the standardization body to get their fuel approved. Of course, after basically going through that process and already having the OEM's approval on that process. I hope that answers the question.
Right. A third one just came in, Andreas. The fuel produced under ASTM D7566. Who certifies this fuel, and what is the certification method? Should I repeat it?
Yeah, no, I think it's okay. So the body that certifies or qualifies that fuel is ASTM, and ASTM is a standardization body. It's situated in the US. So for at least for the fuels that we are talking about today here, and ASTM, as I said, is the globally accepted standard. You have national standards, but they're basically all based on this one, or the DEF stand from the UK. And it's open to everyone, so there's a balloting process in the end. Basically, you have gone through all the qualification processes, which is also defined by ASTM, which I said is open to everyone. So it's a democratic thing, basically, to come up with the qualification process and also of the balloting process. So within this ASTM, you will have, once you're ready with your fuel and with your reviews and research reports, you go to the ASTM review and balloting process, and they will then basically accept or reject the new annex or the new fuel approval. And once it's accepted, it goes then into the specification D7566 as an annex. So we have 7 annexes today, so the next one would be 8. Basically laying out how the fuel should be produced, and once it's produced through that, then it's fit for purpose.
Great. Thanks, Andreas, and thank you for these questions to the audience. Let me just try to re-encourage you to make use of this tool. And if there's any question that Andreas might not have touched, just feel free to come back to us through this question and answer tool. And don't hesitate. Whatever you think is a question at heart, we're trying to answer it.
And if I don't have an answer ready, I am happy to follow up after that.
Yeah. The interesting part is that also helps us and Andreas to improve and to develop and see what your interests are. Actually, that's a two-line communication we are trying to promote here. So again, thanks a lot for making use of this tool and giving also us the opportunity. Andreas, please.
Thanks. So I hope I showed you a little bit that the process to getting a new fuel out there is complicated. So this meaning that it's complicated, and as I said, it can also be lengthy. So I guess 2 years is a good estimate. And it can be a complex and expensive process to go through all that, knowing what to do, especially for new fuel producers. It can be a complex and if it's a small company, the more difficult, of course, it is to have the right and the right amount of resource available for that. So the idea of a clearinghouse was established in the US to help fuel producers with that process, and I will take the second half of my presentation to guide you through that a little bit and what that is, and also an EU proposal on that. So what is a clearinghouse supposed to do? In one word, it supports fuel producers wishing to certify a fuel to ASTM standards. So it provides guidance to potential fuel producers on how that actually works. It carries out tier 1 and tier 2 tests by receiving the fuel samples, and it funds this basically via in the US. It's basically funded through FAA and then through the clearinghouse. And of course, it liaises with and funds also OEMs to review the research reports that are produced after testing. What that means is, of course, it basically, from that standpoint, it simplifies the process quite a bit for new fuel producers. So it basically is a one-stop shop. You come to them, you get guiding communication with the key stakeholders, of course, particularly the OEMs. It provides access to the testing facilities. And as I said earlier, there are also pre-screening tools available that de-risk this evaluation quite a bit, and also the cost. But basically introducing, in the case of the JetScreen program, which was a Horizon 2020 funded research project in the EU, basically developing something called, or they call it tier alpha and tier beta, which is basically already even before tier 1 testing. So you need even less amount of fuel, which is of course then cheaper to produce, to already have an early estimate on how your fuel would fall into the specifications. What it also does, of course, it offers guidance. Often, at least in the past, has shown that prospective SAF producer, they don't have a good understanding of how the certification process works. So the clearinghouse will provide expert guidance and guide them through the process, which is particularly valuable, and I wrote it here on the slide. If a fuel, let's assume a fuel producer comes to the clearinghouse with an idea on a new fuel and already produced a first batch or something like that, and it shows that if a slight adjustment of the production process would mean that the fuel would fall on an existing D7566 annex, as opposed to requiring a new annex, that of course will save a lot of money and a lot of time, because the producer could already go ahead and produce the fuel according to the existing standard. Of course, time savings with the clearinghouse subcontracting OEMs to review the research reports. The availability, of course, at the OEMs is also limited, so it can be better managed they are ready to review the research reports. But I wrote it also here, it's not the main delaying factor to get the fuel through the process. The main delaying factor is historically that the producers have difficulties in producing the necessary amounts of fuel for testing, and we are looking at a lot of fuel for the later tests. I should have added a slide actually on how much fuel needed. I could add that to the presentation once Ralf distributes that at a later stage. But at the same time, with more experience, it can also lead to fuel savings, because with all the testing going on, and of course the research facilities doing that, they know what they are looking for, so maybe the less fuel is needed. And well, it's still, of course, the fuel producer would need to demonstrate how to scale up the production to commercial volumes, so that it would not be stuck forever in any research laboratory scale. So what I talked to now is basically what the US clearinghouse is doing, which is at the moment the only clearinghouse for alternative jet fuels. It was established in 2016, but it builds on significant pre-work. So there was work already done a lot of years earlier, and the clearinghouse is basically placed at the University of Dayton Research Institute. And as I said, the goal is to remove as many barriers as possible to certifying a new fuel. And as I said, build on pre-work, and then the certification work was already done before establishing this clearinghouse. What we at EASA did is we commissioned a study a few years ago. We published it last year or 2020, I'm not quite sure, but we commissioned a study to investigate a SAF facilitation initiative, basically to assess the current status of SAF in Europe. And well, at the moment, SAF in Europe is, I think it's 0.05% of fuel use, so it's very limited. And determine how this could look like, and also establishing assess the feasibility of having an EU clearinghouse, supporting or model after the US version of the clearinghouse. And
Andreas?
Yes.
Sorry again for interrupting.
No problem.
Just to the audience, we have, not to scare you off, Andreas, we have 3 questions been coming in. It would be nice if the audience could look also into these questions and vote for questions that would be most relevant to you, so that the most important questions from the participants would be ranked on the top, and then we can work them off one after the other. So just a short comment from my side.
Okay. So, and the study And I should have said that you can access it at the link below. I think we will share the presentation, right, Ralph, that they can click on the link. And the recommendation from that was basically to set up a European clearinghouse. And what that basically could entail is basically what I already showed you from the US clearinghouse. So potential scope would be provide expert advice to prospective fuel producers on how to go through the D4054 process. This could also include the pre-screening test that I mentioned earlier, the tier alpha, tier beta. It would fund and carry out early testing. This, of course, includes then arranging the tests with the appropriate testing facilities, collecting, interpreting results, and of course also the logistics of getting the fuels shipped through the process. It would act as a single point of contact with OEMs and providing funding. And of course, a new clearinghouse would also it is situated for European producers, and could of course also become a potential option for Asian producers, but similar for the US clearinghouse. So it's not at all in any competition. It only works if cooperation is happening with the US and the EU clearinghouse and any other potential clearinghouse that might be developed somewhere. And this was already when we did the study, appreciated, of course, by the US colleagues that because the more SAF comes, the more it comes into focus, of course, the chance is quite high that the more and more producers want to enter the market with novel feedstocks, novel production pathways. So that could mean that in the future, one clearinghouse is just not enough anymore, and the more clearinghouses, the better, maybe. We will work on that and hopefully have some news on potential EU clearinghouse in the near future. Until then, I will keep you posted. And just 2 more slides left. So not about certification, but so at least not the technical certification, because everything I talked about does not include any sustainability at all. It's a very technical process. Whatever you use as a feedstock needs to be, or production pathway needs to be added to the annex or needs to go through that process. But that doesn't mean that it's a sustainable fuel, right? So that's something different. So you would need, or to at least to be able to be used under CORSIA or to be accepted for EU RED. That means that you would go through certification from a sustainability certification scheme to prove that this sustainability credentials are okay, and improve its marketability to airlines as well as its eligibility for the government supported schemes like CORSIA that I mentioned. For the EU, we have 13 voluntary schemes, I think, approved. And whatever choice of SCS you would use is mainly depends on target market and so on. So this is of course important. Without the sustainability of the SAF, it's pretty not useless. But of course, the goal is to reduce the emissions, so this is an important factor. And what I've not talked about is 100% SAF. If you read the news, it's, or at least the specific news related to aviation and decarbonization, it's always something that comes up. Because, as I said, 50% is the maximum limit. So, of course, that limits also the decarbonization potential. So, the option or the goal is, of course, to in the future go to 100% SAF, that you don't need the fossil component anymore. And there are basically 2 major options. The first one is to use, again, drop-in fuels. Drop-in fuels, as I said, has to have the same composition and properties as conventional A1. That means it could be used in all aircrafts without restrictions. So you don't need to, and also no change to ground infrastructure is needed. And again, the ASTM D4054 process would be applicable. There are already some pathways approved that theoretically could work for 100% SAF, and the work on that continues. They are basically test flights happening, I guess, as we speak, more and more in the future. And the other option would be a non-drop-in fuel, which would basically means a completely new fuel grade, completely new fuel specification, which would not be addressed through, or not in detail at least, through the D4054 process, but that would mean that it's potentially then only for new aircrafts, and that it needs a separate infrastructure because it cannot mix it with the existing fuels. But the positive things, I guess, or you are not bound to the limitation of Jet A1 anymore, which then would lead to more flexibility regarding the pathways. And the ASTM has established a task force, which is, again, I think, open for everyone, on 100% SAF standardization. It was established in February 2021. And I think one of the goal dates is that by 2030 or so, that 100% route is established. And with that, I'm finished for today, and I hope there are some questions. Otherwise, feel free to reach out. I don't have my contact on here, but Ralph will probably communicate that. And Ralph is muted. Ralph, you're muted. Still not anymore.
Better now?
Yes.
Okay, good. Thanks.
I hope I wasn't muted for 40 minutes.
Andreas, let me try to do one thing and share the questions that we have received, but I don't think you can see them now, right? I see your final slide here.
Should I stop sharing then maybe?
If you could do that, yeah, for a moment. No, let me just go back here. 1 second, please. Ask for your patience. So present. Unfortunately, it doesn't. So I have to, or I'm going to read the questions from the right side. And I think everybody, also you, Andreas, you can see these questions, right? So it's not as nice that it eventually could be, but it is 3, if I'm not mistaken. These are 3 questions. So the first one, or it's 4 now, it is, do the oil producers need to go through ASTM 7566 again if they use technology from licensors? So if they use it from licensors technology, do they need to undergo the ASTM 7566 again?
So I guess you mean D4054, because let's assume you are producing a fuel that is equivalent to one of the annexes in D7566, then no, you don't need to go through this process again, because basically you are adhering to an existing standard.
Second one, who have been funding these ASTM approval process pathways? Who is the funder behind this?
So the ASTM process per se is free, so you don't have to pay a fee to basically go through that process. But of course, what costs money is the testing and the fuel production. The fuel production, of course, falls under the fuel producer's responsibility, so he would pay for that. And for the funding of the testing and maybe also the OEM's review, that is where the clearinghouse comes in. So the clearinghouse takes over some of the costs, and a lot of the OEM contributions is in-kind sharing. So there's also no real payment going on there.
Mm-hmm. Andreas, a very interesting question here, and that concerns a thing that has been touching us as an issue, as a subject on various times, but I think it hasn't been implemented yet, but you probably know more. It is the use of algae. And the question on that is, if you have informed algae is allow for 10% blending, and how is the process to increase it to 30 or 50%?
Yeah. Yeah, so the algae one is exactly the most recent one that was added to the annex, and the 10% is very conservative, and it's due to the fast track approval, so they didn't go through all the testing. And I discussed that earlier with a colleague, and we assume basically that if you want to have the higher percentage, you would need to go through the D4054 process. So in the case, I guess that would mean for this Japanese corporation that came up with the production pathway, they would in the future maybe apply for going through the whole process to get it approved once, I guess, some kind of more commercialization has happened with the production pathway.
I have a last one for you, Andreas, as long as no one else is asking something more, but we have still 15 minutes. There's the question asking the submission for the fuel review process is by the crude oil producer or by the final fuel producer or a combination of both, crude oil producer and final producer?
I'm not sure what is meant by crude oil producer, but I hope I understand it correctly. So
that comes from Robert. Robert, if you can clarify that, just add if there's anything missing to the question that Andreas.
But in any case, the final fuel producer, I guess, is responsible for submitting or going through the process, because you have to have a final product to get it tested, right? So just the feedstock is probably not enough to go through the process of testing a jet fuel for testing.
And Andreas, Robert is just saying,
algae.
That's an example, algae crude oil.
Okay, yeah, so I guess my answer then is still the same. so the final food producer would go through the process. And happy to follow up with more detailed discussions with Robert if that's helpful.
Very good. So it is now, and we have done this on purpose, Andreas. We have tried to place this webinar at the end of our colleagues' working days in Southeast Asia. So I think that might be the right moment for me to thank everybody for attending the third webinar, and I would like to ask you to stay tuned for more. And while I'm talking about it, I'm trying to get back control over my presentation tool here. And let me just share 2 more slides with you. And I hope this can be seen in a moment. Andreas, if you can just give me feedback if you see something.
Yes.
Oh, very good. Very good. So again, the moment to thank everybody for being with us, and again to you, Andreas, for taking the time. This was the third confirmed workshop, and we are working on in total 5 more to come. So please stay tuned. We're going to let you know as soon as we have the final confirmation on airlines' experiences on sustainable aviation fuels, probably happening end of July, and talking about SAF benefits beyond CORSIA, probably early August. So these are the 2 next webinars going to be confirmed very soon. We're expecting them to be confirmed. We are working, just as a background, together with many, let me call them sponsors, colleagues and experts from the industry, from EASA, like Andreas today, from the European Union, from the academia research institutions. So these are voluntary partners, and by the moment they are ready to share the hour or 1.5 hours with us, we're going to let you know, and please stay tuned. Also on SAF sustainability certification schemes, the role of the airport acting as a SAF hub, it's also on our agenda, and environmental reporting. So thank you so much for your attention, and we are wishing you all a very good rest of the day. Thanks for being with us. Bye.